Hello, this is my video presentation about my topic, which is cold weather concreting. Temperature in different regions vary from windy, cold, hot, and so on. Yet, all people around the world are bound for using concrete, so what's different when the weather is cold? Well, in cold weather there will be problems, which rise from the action of frost. In these cold temperatures, the water in the concrete mix could freeze. When the water freezes, there will be a reduction in the content of water in the mix, and this will cause the hydration reaction to stop, and thus the concrete will stop gaining strength. So it is required that the concrete doesn't freeze in the first 24 hours, not until it reaches a strength of 500 pounds per square inch. The American Concrete Institute defines cold weather concreting as a period when for more than 3 successive days the average daily air temperature drops below 40 degrees Fahrenheit and stays below 50 degrees Fahrenheit for more than one half of any 24-hour period. It's usually required to heat one or more of the concrete components, either water or aggregates, sometimes both are required to heat. If the aggregate temperature is below 0 degrees Celsius, then it is required to heat both water and aggregate. Some problems associated with cold weather concreting are delay in setting time and hardening, and that is due to the water that will freeze, which will cause hydration process to stop. Freezing of concrete at an early age, so that's why concrete shouldn't be allowed to freeze before it reaches a certain strength, because if it freezes, it could stop gaining strength. Freezing and thawing cycle. When concrete freezes, there will be expansion, and when it thaws, that expanded volume will not go, and the thaw will cause durability issues. To encounter that, air bubbles are entrained in the concrete, so air entraining makes concrete resistant to freezing and thawing. There are different ways to measure the air content in concrete, which are gravimetric, volumetric, and the pressure method, which is the most reliable. The pressure procedure requires to observe the degrees in volume of a sample of compacted concrete when subjected to a pressure applied by a small slump. And these are the recommended air contents of concrete according to the ACI.